Thank you for buying a GasGas. This is Dale Malashik of GasGas USA Incorporated, the importer of this bike into the USA. This is your Video Owner's Manual DVD for all GasGas Pro Trials models only. All other Trials and Pampera models are available on a separate DVD. The maintenance portion of this video was done at the offices of Rising Sun Imports, who is the GasGas parts importer for the USA. Shortly, Jim Snell will explain the changes in mechanical operation and repair of the new Pro models. Because setup and system maintenance is essentially the same as previous Trials models, we have used some information from our previous maintenance videos. All GasGas motorcycles purchased new through GasGas USA Incorporated and its dealers carry a 3-month warranty from the date of purchase. This warranty covers manufacturing faults and defective materials, and these items will be replaced free of charge if submitted to the factory or any authorized GasGas dealer for inspection. This warranty is void if the motorcycle is repaired by other than an authorized dealer or service center, or when used for racing or rental, or when operated in a non-approved manner as determined by the factory and the importer, GasGas USA Incorporated. GasGas USA Incorporated will not warranty nor provide service or support for any GasGas motorcycle which has been imported into the USA by any other company or individual. The factory, GasGas Motors SA, and the importer, GasGas USA Incorporated, and the GasGas dealers disclaim any responsibility for any accident or injury which may occur as a result of the use of GasGas products. The purchaser and/or operator of the motorcycle is entirely responsible for any liability, injury, and damage which may result from accidents involving this product. It's very important to check your bike over frequently. Most problems start from something coming loose or being neglected. Thanks again for buying a GasGas. I know you will enjoy your new bike.
Greetings. Welcome to the GasGas Maintenance Video Production. My name is Jim Snell. My company operates the United States National Distribution Warehouse for parts and accessories for GasGas Trial and Pampera motorcycles. At my facility, we also operate the research and development for the United States. In this production, we will be showing you procedures for normal maintenance on your new motorcycle. The GasGas dealer network in the United States is highly qualified and well established. If you need any assistance, please consult your local dealer. In this video production, we are attempting to show you ways of performing maintenance on your motorcycle so that you will have very few problems with the motorcycle over the lifetime of its use. If you are uncomfortable with any of the procedures in this videotape, or if you do not possess the mechanical aptitude or the proper tools, we would suggest that you would consult your local dealer to assist you. As we have been importing to the United States the GasGas trial motorcycles since 1991 and producing prior versions of this production, you may notice in some of the segments that the motorcycles depicted are of older models from prior years. In this production, we have chosen to reuse some of the original footage, and these segments will be when the basic procedure does not change. So therefore, when you see the older motorcycle, you can assume that the procedure shown there would apply to your new GasGas motorcycle. Additionally, you may wish to access the GasGas USA website on the World Wide Web at gasgas.com. At this website, there is a technical forum. You may wish to review some of the technical advice. There are also wiring diagrams and many other items of useful information. Also are the results of GasGas racing worldwide and many other things, photos and tests and product reviews of the entire GasGas motorcycle selection. Here we have the 2003 model GasGas Pro, this being a model 280. We have for 2003 some changes to the motorcycle. We have a new disc brake rotor on the front. We have a new type of dust sealing wiper on the forks. We have a minor change in geometry and some reinforcement to the frame in this area. We have a new efficient cooling fan which draws less current from the ignition and operates at a higher RPM, which can bring the engine into its proper temperature operating range more rapidly than the previous model. We have on the 280 model a new carburetor from Del Orto. It's a flat slide developed exclusively for the sport of observed trials. And again, this would be an exclusive item on the 280. You may notice one additional mounting screw on the magneto cover and a minor change in this area. We now have the engine center cases in the material magnesium. In 2002 they were aluminum. This is a 1.7 pound weight reduction to the engine assembly. We have a new chain for 2003 developed exclusively for trials. We have a new airbox seat. It looks the same, but it has some changes in its structure and design for strengthening and ease of maintenance of the filter element. There is a model available for those of you with 2002 machines which has the correct 2002 graphics, but it's actually the 2003, and this is an update part that's available from your GasGas dealer. In addition to some changes to the airbox seat assembly, there are some rubber flaps that have been installed in the chassis for waterproofing purposes, and there is a rubber flap that's on the shock body itself, and this assembly that's available for the 2002 bikes is offered through your GasGas dealer at a very reasonable price so that you may upgrade your older machine. For 2003 we also have a new exhaust system from this point to the rear. This centerpiece is redesigned and reinforced and has an improvement in performance, as well as the rear silencer has changes to the way it mounts and the way it joins with the center exhaust in this area here. In addition to the exhaust enhancing engine performance, we do have a change to the cylinder head. The purpose of these modifications was to make the bike have smoother bottom end, low RPM power. On the engine also we have the external clutch cover has been modified for 2003, and I will speak about this component in a moment, but also this is available as an upgrade part. There is a kit that you can install this new cover on the 2002 bikes, and again it's offered at a reasonable price through the GasGas dealer network. Here I have the 2003 cover, and this component is also magnesium. We have some changes in here this year. This rib is new, and this is to direct oil into the clutch to enhance the cooling of the clutch components. And we have a change in the seals in this area, and also the diameter of this post and the piston that sits here are smaller, so that with this cover the clutch opens a little more when you pull in the clutch lever. This kit comes with all the necessary gaskets and components to upgrade the 2002 model. For 2003 we have a minor change to the design of the rear disc brake rotor. After loosening the two carburetor clamps, I can pull back on the carburetor and actually remove it from the chassis without removing the air box. Okay, so we can remove the carburetor like this, and we can on the throttle cable up here, we can give us a little bit of slack so that we can remove the top of the carburetor here and pull out the slide, then work on the carburetor on the workbench. Here we have the flat slide. Always inspect your O-ring that's inside your cap. Make sure it's in position when you reassemble your carburetor. To remove the slide from the cable, there is a little side slot that you can pull the cable out. Then we have an 8mm socket as necessary to loosen this nut, which retains the needle if you want to make a needle clip adjustment. As with all Del Ortos, when you have the floats out, be sure that this pin is on the bottom. It is possible to install these incorrectly. So this would be correct. On the new 280 model flat slide Del Orto, this is your pilot jet. It's exclusive just to this carburetor. All other Del Ortos on other GasGas trial models will use this pilot jet. So when ordering a jet for the pilot circuit on your 280 for year 2003, be certain that you specify that it has the new type flat slide Del Orto carburetor. The standard jetting on the 280 model for 2003 is a number 36 pilot jet, a number 107 main jet. The needle is a D48. The needle has 5 clip positions. From the factory, the setting is the second clip position up from the bottom. Due to the constant development of the GasGas products, we have some variations in front suspension in the model 2002 and 2003. This also would apply to the economy model, more commonly referred to as the Edition. You may notice on your motorcycle that the forks, when you receive the motorcycle new, they may not be in exactly this same position. They may actually be down inside the clamp a little or above the clamp a little bit. If you find this on your motorcycle, it is best to leave it in that position. That's the position that the factory has chosen for the best chassis performance of your specific model. It's possible on some of them that have the fork actually inside this top triple clamp, that if you were to raise it, it is possible that the dust seal area here would impact the bottom of this bottom triple clamp. So if you are thinking of making a change to the level of the fork tubes in the triple clamp, it's best to be certain that you don't have this problem with this impact. The reason for the differences in length is because they have realized, due to the developing way of riding in the World Championship and the way that the chassis geometry is developing in the sport, that the previously longer travel front suspensions are no longer needed for today's motorcycles. With the motorcycle on a center stand where there is no weight on the front wheel, this will give you complete extension of the front suspension. You should have a measurement of about 7 inches, 6 7/8. The minimum should be 6 3/4. Anything less than 6 3/4 and you stand the chance of an impact of the dust wiper into the bottom of the bottom triple clamp. We have a large tapered bearing here and down here that the steering pivots on. This is important that it be kept greased and adjusted. And this would be the tension nut, which puts the proper tension on the two bearings and the steering. When you adjust this nut, you must loosen this bolt and loosen the two pinch bolts that pinch this to the leg. Then you can tighten this, and you can use a spanner or a small punch and tap it. And then you want to have smooth movement here, and you should pull like this on the tire and check for play in the front suspension. If the bearings are too loose in there, you'll be able to actually move the forks back and forth. You'll feel play in this area. And after you have this adjustment made, then you'll need to tighten this nut. And again, this must be loose. This is a jam bolt which goes into the side of this nut to lock it in place. So then after you've tightened this one, tighten this one, tighten this, then you'll go back over here and tighten the two front bolts, one on each side, that pinch this clamp to the leg. You must have these loose during this procedure, so as this comes down, it can move down also on the forks. So at the point we're going to make this adjustment, it may be just as easy to remove the handlebars, take off this big nut, and with the pinch bolts loose, remove the top triple tree and remove this nut, and then you have access to the bearing here, and you can drop this assembly down a little bit, and you can get in here with a paintbrush and put grease on the lower bearing, thoroughly grease the top bearing, then reassemble, make your adjustment. This may add 5 or 10 minutes to this job, but keeping these bearings properly greased is essential for the performance of the steering of your motorcycle. I also want to mention that it is best to avoid pressure washing this area, because you can force under high pressure soapy water, which will accelerate corrosion in the bearings here and wash away the grease. This is the new TXT280Pro. In this segment of this production, we will point out the primary differences between this motorcycle and the previous models. For 2002 in the Pro model, we have different clutch and front brake master cylinders. Please note that the internal components on these master cylinders do not interchange left to right. The internals are different. We have a new, smaller, more compact front clutch master cylinder. The internals in the front suspension are different. However, the procedure for exchanging the fork seals explained elsewhere in this video will be the same as the previous models. We have the new 32 spoke front and rear wheels with new hubs, new disc brake rotors, and new 4-piston caliper with aircraft type high pressure hydraulic hoses. The new chassis on the Pro model uses chromium plated chromoly ovalized tubing. The new Pro model uses a completely different engine, designed and built by GasGas, 6-speed transmission, liquid cooled, 2-cycle case reed valve. A completely new fuel tank with the same fuel cap as previously mentioned in this production. A composite resin seat base with integrated air filter box. A detachable rear fender. A completely new rear swinging arm, rear brake, rear wheel hub and sprocket assembly with a rear brake caliper now protected internally in the swing arm, 2-piston design. On the Pro engine, we have the clutch slave cylinder for the hydraulic clutch built into the clutch cover, a small window here for checking the oil level in the transmission clutch, of which it should be 350 cc's for viscosity and oil type. Contact your dealer. We have a new completely redesigned water pump assembly, direct driven off of the right hand side of the crankshaft. To access the air filter element on the Pro model, we will remove one screw from the rear of the seat. The seat lid is lifted up and removed. Inside you will find the filter element, and in the center of the element is a small wing bolt. Reaching in and loosening the wing bolt, you will remove it, and then you can remove the filter element from the motorcycle. After unscrewing the bolt, we remove the air filter assembly like this. This is the bolt. The filter itself is in a small plastic cage. This is similar, you may be familiar with this design with motocross and enduro machines. This is the cage. We have, again, a oiled foam filter element cleaning and oiling procedure explained elsewhere, and being certain that you have the filter correctly installed on the cage. You can see that you have this center hole, and the filter is not in the center of the filter itself, and the same with the cage. So obviously the filter has a specific position that it goes on. Then you have a lip on the filter element which goes over the cage itself. You can see like that. Then when this is reinstalled, this is sealed into the inside of the air box. Now, the high point in this cage goes up when reinstalling the filter. So this would be in the upright position here. Here we have the surface that the filter seals against, and in the center here is where the wing bolt attaches. So the filter and its cage sits here. In the bottom of the air box we have a water drain hole. In case some water may get into the air box, it actually will go below the filter area and then drain out through that small hole, which has a little rubber seal on the bottom. The air box breathes up here on top in the front. This is the only place that the air comes in into the box itself. Here we have on the bottom of the air filter box a burp valve. By squeezing it like this, you can drain any accumulated water that on a rare occasion may be inside the box. This may also drain under the force of gravity. When the engine is running, the suction of the engine will draw this into a closed position. So squeezing it from the side, you can see opens a small orifice in the bottom, allowing any water to drain. To remove the airbox seat and rear mudguard fender assembly, we have 4 countersunk Allen bolts here on each side. Then we will loosen the hose clamp at the rear of the carburetor, and then pull back on the entire assembly and pull this rubber boot at the back of the carburetor, pull it to the left so that it can come around the side of the rear shock absorber. There. This boot goes in the back of the carburetor here. Here you can see the small drain for the air box. This is the air entrance hole for the air filter. This is where the air is drawn into the air box. When reinstalling the air box seat base, it's best also to loosen the front carburetor hose clamp. This allows you to move the carburetor slightly during installation. Be certain that the rubber intake hose to the rear of the carburetor from the air box is correctly installed on the back of the carburetor. And then tighten the hose clamp, and then you can tighten the front hose clamp, and then put the remaining bolts in on the assembly. Here we have the rear shock absorber for the Pro and also on the Edition 02 models. On the bottom of the shock, accessible underneath the motorcycle, is the adjuster for the dampening. Now this screw adjusts rebound and compression dampening simultaneously. You'll see a small minus and plus symbol imprinted in the body. Using an 8mm wrench, you can rotate this to adjust the dampening. Minus means less dampening and plus means more. The shock is delivered from the factory on your motorcycle in the fastest position, which is all the way to the minus side. There are no clicks, and this screw will rotate 2 1/4 times. Caution, it is possible to break this off if you are attempting to turn it when it's already in its outermost position. If you feel resistance, do not force this. This turns very easy, just like that. But when it comes to its end, it is possible to break this. Here we have the rear shock and the rear brake master cylinder reservoir. Incidentally, there should be an air gap in the fluid to allow for heat expansion. You should not overfill this reservoir. This is the preloaded adjustment for the rear spring. If you're heavier or as the bike ages, you may find it necessary to add more pressure to the spring, and to do that you will loosen the top one of these 2 nuts and then you will rotate this bottom one to preload the spring, and then when you tighten the top one against the bottom one, you have them locked together, and that prevents them from coming loose. On the top of the front suspension fork legs are two knobs, one on each side. One knob is marked C, which is compression or adjusts the dampening when the fork is going up. On the opposite side is one marked E, which is extension or rebound dampening, which adjusts the dampening when the fork is going down. Again, we have plus, meaning adding dampening, minus, meaning less dampening. Please note that these are high-speed dampening adjusters only, so depending on your skill level, you may notice no change when you move these knobs because they only affect heavy impacts and retractions of the front suspension. The new ignition system on the Pro model is Kukusan Digital. There are no provisions for altering the timing. However, it is critical that this pickup have the correct gap, and the gap between the pickup and the flywheel is 0.7 of a millimeter, and you check it with a feeler gauge like this. Then you can adjust this pickup by loosening the screws. 0.7 of a millimeter. To remove the flywheel from the Kukusan ignition module, you will remove a bolt from the center and the standard flywheel puller available from your GasGas dealer for specifically Kukusan units. This puller fits 1996 to present Kukusan ignitions on GasGas motorcycles only. You'll insert this threaded puller tool, and when you turn in this part, it will press the flywheel weight off of the tapered shaft on the crank. Note that there is a Woodruff keyway on this flywheel, so when reinstalling it, you must be certain that you have the Woodruff key on the crank aligned with the keyway in the flywheel. This is the digital Kukusan ignition stator. These windings are for generating AC power, alternating current, which is used for your lights and for your cooling fan. This winding is to generate the spark. This, of course, is the tripper coil, and then when the signal is sent from here, it goes into the black box or the advanced module, which decides when to fire the spark plug according to the RPM of the engine. Note, because of the more compact design of the new Pro engine and the smaller oil capacity of the transmission clutch, that you will want to change the oil more frequently. The oil drain plug is in the center of the bottom of the engine cases, accessible through the round hole in the engine skid plate. On the oil drain plug is a small magnet, and when you take the plug out for changing the oil, be certain that you clean the magnet to remove any material that's stuck to it. To put new oil in the motorcycle, this is the access plug here, and it's the same size Allen wrench as the drain. To gain access to the clutch, and also to show you the new features of this new engine, we will first remove the 3 mounting screws from the water pump. Please note that there is one that's longer. That would be the one on the bottom. You will wiggle the water pump and pull on it, and it will come off the engine. You don't have to drain the cooling system to do clutch maintenance. If you do want to drain the cooling system, this brass bolt here is, when we're removed, will allow the water to drain. The water pump seals to the engine with an O-ring here. Then you can place the water pump to the side and hold it with some string or a rubber strap. Looking at the inside of the water pump, we see here the shaft which drives the impeller. The brown color in there is the water pump seal. To do maintenance to this device, you will remove the snap ring, which is visible there on the interior, and the components come out this way. This pin going through the shaft will fall into place in one of the 2 cutouts in the end of the crankshaft here. So when reinstalling this, be certain that you have proper alignment of this pin with the crank. Now we're going to hold the water pump out of the way with a strap. Here we have the water pump assembly for the Pro. The components that are inside the water pump are shown here. Note that the water pump shaft and the impeller are opposite the normal threads. This is counterclockwise to install the impeller to the shaft. This is because as the shaft rotates against the pressure of the water, the impeller will be self-tightening. To disassemble the water pump, we will remove this bushing here. It has a nylon washer seal. Inspect this. This is the water pump shaft that you see inside. There is a small washer there. Now, to remove this interior of this pump, we will take a snap ring plier and remove this interior snap ring here. Then I will take a small screwdriver and I'm going to insert it in here to stop the impeller. And so essentially what I'll be doing is I'll have the screwdriver in like this. So I'm putting it in here against the impeller blade, and then again, because the threads are opposite the norm, I will actually be rotating this shaft as if it were tightening it, but in reality I'm going to be removing it from the impeller, and it comes out like this. Now we have a small washer that you may recover later, or if you're lucky it may fall out. There it is. It goes on top of the impeller when you're reassembling, and then this piece sits like that. And this is actually a bushing bearing for this end of the shaft. Now, we are going to remove the seal, and there's several ways you can do this. You can actually heat this aluminum piece on a hot plate if you want to slightly expand it to break the seal of the rubber against the metal. Many times it's possible just to pry the seal out. We can use a screwdriver, a fairly large one, and if we're lucky we can just get a hold of the seal like this. We're going to ruin it, but obviously our intention is to replace it, and very carefully. We don't want to damage the housing of the water pump. And if it gives you some problem, then you may want to heat this in, like I explained, on a hot plate or using a heat gun. And be careful when you're doing something like this that you don't impale yourself with your tool. Okay, so I've heated the housing a little and the seal is going to come out no problem. And we have our impeller that we'll remove from the housing. You wouldn't want to heat this too much. You might melt this, but just a little heating on this was enough to expand this and break loose the seal. We'll clean all the components before we attempt to reassemble it. Okay, so I have my shaft, my new seal. Note that the seal goes this way. The other side of the seal is completely brown. You'll see the recessed area will be visible on this end of the shaft. I've reinstalled the impeller, and I've lubricated the seal and the area around the outside of the seal with silicone grease, and also I've cleaned and lubricated the interior of the housing. Notice there is the snap ring groove. We'll be wanting to press the seal in just as far as it takes for it to just get past that groove. So obviously it goes in like this. Now I actually have found a socket that is perfect for using it as a tool. I'm using the socket like this, and it sits very nice down in the seal, and you can then press the seal in place. And if you have any problems using this method just with your hands, if you need to, you may put this in a vise and very lightly, but you can see that I can do it just with my hands. And again, you only want to press the seal just as far as it takes to clear the snap ring groove. I have the snap ring reinstalled. If you want to test rotate this assembly, remember always counterclockwise. If you were to rotate this clockwise, it's possible that you would loosen the impeller. So always testing it counterclockwise. We have a smooth movement. Then again, we have this small washer that is going to sit on the shaft first before this bushing. So I'm going to take a small amount of silicone grease and lubricate this area, and then I can put the washer there and put it back together. And we want to tighten this just snugly because we don't want to squish that nylon seal and damage it. Then once again we will test, and we have nice smooth movement. So as I mentioned previously in this video, that I prefer to align the pin with this bottom water pump hole, mounting hole, and then I align the crankshaft of the engine the same way, so that when I reinstall the water pump, these components align. You may find that if you remove the small O-ring which sits here and make an initial test fit of the pump to the engine to be certain that everything is falling into place, then you can carefully remove it, put the O-ring on, and then reinstall it, and then you're certain that you have these components aligned correctly and that these pins have fallen into their position on the drive of the crank. I want to mention that really you should not attempt to force this component onto the engine. If you have resistance, then you should double check your work to make sure that you have all the pieces properly aligned. There are three basic reasons that you would need to remove the clutch cover. One would be to make an adjustment to the eccentric cam for adjusting the shifting mechanism. Another reason would be to make adjustments or repair to the clutch fiber plates. And the third reason would be to make adjustments or repair to the slave cylinder, which is built into the interior of the clutch cover. The clutch cover on the new Pro engine is a simplified design, and to remove it to gain access to the clutch components, you will need to remove the kickstart lever, and I would like to show you a little tip. This lever is on a tapered spline shaft, so you would remove the bolt just partially, and then when you open the lever, you can use the lever itself as a lever to pull it loose from the tapered spline. And then once it's loose, you can take the lever off of the engine. Here we have the water pump. This brass fitting is also the drain, so if you need to drain the water, you would remove this. However, if you're going to do clutch maintenance, it's not necessary to drain the water. When you remove all the bolts around the perimeter of the clutch cover, including the 3 water pump bolts, you can take the water pump off of the clutch cover and pull it aside and never disturb the cooling system, or you can leave the water pump attached to the clutch cover. This would be the hydraulic line going into the clutch for the slave cylinder. This is the hydraulic fluid coming from the master cylinder on the handlebar, which opens the clutch. It's also not necessary to disturb this when you remove the clutch. When you have all the bolts out of the clutch cover, you can release the cover from the engine by merely pulling on the clutch lever, which presses on the slave cylinder, which is in here, which will press the clutch cover loose from the motor. Here we have the unique GasGas Pro clutch. To exchange the fiber discs on the clutch, you do not have to remove the assembly from the engine. However, we're going to take this off to show you how it attaches. To get the clutch basket assembly off, there's one Allen bolt which uses a thread locking sealant that's in the center, and you remove that. And then you remove this clutch by wiggling it from the spline shaft that is the engine shaft, and then you have here the entire clutch basket and clutch pack. To exchange the fiber plates, of which there are 3 shown here, you will want to remove all of these little bolts, and please note that these need to be loosened a little bit at a time, each bolt, so as not to cause warpage to the large spring. This item right here is the spring itself, which applies the pressure to the clutch. Then when you pull the clutch lever in on the handlebar, the slave piston that's inside the clutch cover presses on these fingers, which opens the clutch. This gear here is the kickstart idler gear. When you pull on the kickstart lever, this toothed piece engages to this gear, and as you're pulling the kickstart lever back, it rotates the clutch assembly, which starts the engine. Of course, this gear is the right-hand side of the crankshaft itself, and this area previously shown is where the water pump is driven. This piece here is the clutch lever return spring. When you're shifting down from a higher gear or from neutral down into first, it would go that way, and then upshifting would be like this. And this spring is what gives your lever the return feel that returns it to the neutral position. This assembly here attaches directly to this shifting drum that's inside the engine cases, which then actuates the forks which move the gears and the transmission. This design is unique to the GasGas Pro model. When you remove the cover from the side of the clutch, when you pull it off, be aware that typically this washer will stick here to this cover. The washer needs to be on the kickstart shaft, like that. Also be aware that this little foot on the kickstart shaft will need to be aligned properly so that it goes into this recession in the clutch cover when reinstalling. Be very careful that you have this in this position. On the clutch cover itself, this would be the piston for the slave, and there is a washer with a lip, and this washer, as I show, and where it goes is here. So it must be reinstalled correctly, like this. Under it is a bearing, and we'll discuss later the rest of the components here, but we have a spring and some O-rings, and this being the piston. Also, this is the water pump drive. If you take the clutch cover off with the water pump on the cover, or if you've removed the water pump beforehand, keep in mind that the end of the crankshaft has a cross pattern notch in the end of the crankshaft itself, and you must be certain that this pin falls into the crankshaft for proper alignment on reinstalling the water pump and clutch cover. The unique spring design on this new clutch, we have here a Belleville spring, and this exerts a tremendous amount of spring pressure to these 10 bolts and this plate. The bolts, to remove them, it's best to use an Allen wrench, and then when you pull pressure on the wrench, to take a small hammer and to tap lightly on the bolt, and the bolt will release. This is the best method to release these bolts. When removing the clutch assembly from the motorcycle, in the center, down in here, is an Allen bolt. And please notice, this Allen bolt has a hole directly through the center of it. This is so that the engine can breathe through the crankcase vent hose. You must be certain that you use this same bolt when you reinstall the clutch. This bolt sits in a bushing that looks like this, which is down inside the clutch hub. Once you've removed the bolt, you can remove the clutch assembly, the basket, and everything from the engine. You can sometimes remove it very simply with your hands. Other times it may be a little stiff, so very carefully you may use some type of a device to lightly pry, but be certain that you do not damage the delicate engine cases. It doesn't take much effort to work the clutch free from the transmission shaft. And here we have the clutch and the basket, which is here. And again, we have a washer that sometimes sticks, which that's this washer, and it goes here. Then the basket sits like this. And here you can see plainly the gear spinning, which is what the kickstart lever engages, which spins this, which then turns the crank, which starts the engine. The design of this clutch features these 10 small levers. The correct position of these levers is with an upward tilt, as you can see here. This clutch I'm holding is on the lower side of the tolerance of these levers. They can actually appear higher than this. If you see your clutch levers are relatively flat, as shown here, it may be necessary to make an adjustment to the clutch by changing the metal plates. Inside the clutch are 3 fibers and 2 metals. The original metal plates are 1.5 millimeters thick, and we have optional 1.4 and 1.3 plates available. When you put a thinner metal plate in, you essentially are narrowing the clutch pack, which raises the levers. You can see here when I press down that the levers rise. The metal plates and fiber plates will last a long time because of the excellent pressure that the Belleville spring applies to the assembly. However, over time it may be necessary to make this adjustment. After removing the 10 small screws, you have this ring here which applies pressure to the Belleville spring, which you can see here. The Belleville spring is beveled, and when you tighten this ring down, that is making the spring apply its pressure to the clutch. We then have a pressure plate here, which is perfectly flat, which the outer fiber disc contacts, and this moves up and down. When you press in the clutch and these levers drop, they lift this pressure plate against the pressure of the Belleville spring. You have these 10 little finger arms, pressure release arms. They're all exactly the same, and they're perfectly flat. It is not critical whether they're this way or that way. However, you can see the mark on the spring. The mark that is farthest away from this edge, it would be the bottom side of this arm. You can see this mark is closer to this edge. This would be the top. If you feel you need to install these, you can turn them over, but it would be best to keep them all in the same position, whether they're this line is up or this one. They should all be the same. And you'll need to take these out when you take out the clutch plates, because they overlap the first metal disc. Then when you lift the first fiber, you'll see under it the first metal, and then a fiber, and then another metal, and then another fiber. And here we have this base plate that the inner fiber disc makes contact with. This spline here is what inserts into the transmission shaft. When reassembling, if you keep these two components, again, as I mentioned before, if you keep them together, it makes the assembling of the clutch easier because it keeps the components in alignment. Now, if we were going to make an adjustment to raise these levers for the adjustment I spoke of previously, we're going to take our disc, which is slightly thinner, and install it either here or in the one disc below, and then we will set aside the original that was 1.5 millimeters thick. Then when we reassemble this, you can put just 5 of the 10 screws in, leaving every other one out, and then make your measurement to verify that you have these fingers within the correct tolerance. After we have removed the 10 screws, the plate, the spring, the pressure plate, and then we remove our 10 little levers, which look like this. They're all exactly the same, and there is no top and bottom. They're symmetrical. We have our clutch pack. We have 3 fibers and 2 metals. Now, the correct width of this entire pack, which you can find a diagram for these specifications at GasGas.com in the technical section. We have a clutch pack width which is correct to be 9.75, 9.8 millimeters. If it's above 10 millimeters, then you may need to make an adjustment to this pack to return it to the correct measurements. The reason this is necessary is over time it's possible that the fiber discs may swell slightly, and then you can adjust this by changing the metal discs. There are 3 thicknesses available. The original is 1.5 millimeters. There's 1.4 and 1.3 available. So if we want 9.75 and we have 9.95, then obviously we could take a 1.5 out and replace it with a 1.3, and then we would be returning to 9.75. Or we could put 2 1.4s in. Obviously you're doing some math with these metal discs to return the whole pack to the spec width, which then puts the fingers back into the levers, back into the correct position. And it is normal for these to sit like this. So when you have the correct clutch pack width, you will have the levers in this position. And you'll want to also inspect your fiber discs, make sure that the material is intact and in good condition. And I want to mention that on the fiber discs, you may see these straight lines in the fiber material at 12 o'clock, 3, 6, and 9. When you reassemble the clutch, you will want to place each fiber disc to these we will refer to as tangs. You will need to move the next disc 2 tangs clockwise, and of course you have a metal in between each one, then a metal, then your next disc 2 tangs clockwise. This will give you proper operation and proper flow of oil through the clutch pack. As I mentioned, there is a measurement here, and we're checking to see that these fingers are at the correct height. It's normal that they be loose like this. That's just the way it's designed. What we're going to measure here with the clutch in this position is the distance from the top surface of these fingers, and incidentally they should all be level. If one is not level with the others, you want to check all your components for some kind of a fault. And you're going to measure from this top surface down to this flat surface here on this inner hub. Now you can do that with a caliper by setting the caliper on top like this and just letting the caliper arm go down in there and then take the reading. Or you can use a metric straight edge and you can set it down in there like that and get your measurement off, again, the top surface here out at the edge of these. The correct measurement, the minimum is 16 millimeters and the maximum is 19.5. As the clutch fingers drop towards the minimum, you may notice that the effort required at the handlebar lever increases. When the levers are at near their highest tolerance, you may notice that the effort at the handlebar lever is very easy. I want to mention that there is a measurement that you can make on the clutch here, and I want to point out the features of the unique GasGas clutch here in respect to the fact that it's adjustable. The interior of the clutch hub has a machined surface that you can see here. And taking our caliper, we will rest the caliper on the fingers and reach down inside and measure to that point. And we have on this clutch 19.5. Factory spec is 17 millimeters plus or minus 1. However, I want to point out that when the fingers are higher, which 19.5 is the outside edge of as high as these can be, when these fingers are higher, the levers, the clutch opens slightly easier and has a more progressive opening and closing. When the fingers are lower, the clutch opens and closes quicker, but has a slightly harder lever pull at the handlebar. This way you can adjust the clutch to your riding preference. It's possible that on your motorcycle, especially if it sits for a long period of time without use, that you may experience that your clutch has no resistance in the lever, that it just pulls very easily and that the clutch does not open or disengage. If that's the case, then you may have a problem here in this hydraulic master cylinder, but probably it is a problem that's here in what we commonly refer to as the slave cylinder. This slave has a piston. Some people call it the top hat because that's what it looks like. And it has this spring which just keeps tension on the parts. It has two O-rings. It's possible that these O-rings may swell or become damaged, which will cause either brake fluid to leak out of the system, or it can cause transmission fluid to come into the fluid system for the hydraulic clutch. I will show you a procedure on repairing this. If your clutch pull at the lever is really easy and the clutch drags excessively, which means that the clutch is tending not to release, you may have a problem with these O-rings that are in the slave cylinder in the clutch cover, and you may need to replace them periodically. When you remove this piston, there is a spring, then you'll find two O-rings that are sitting in these two grooves. Typically they will be two black O-rings, or it may be a black and a red O-ring. If it's the reddish brown O-ring, it will be in the groove that is here, most inboard on this post. You'll replace these rings, then you'll reassemble these components. Then it will be necessary to bleed the system to purge the air, and you'll use the method that I discuss elsewhere in the video, and it's the same as working on the brakes, where you use an injection into the bleeder nipple, which is on this side of the clutch cover right here. I've removed the piston, the spring. Now with a small pick I can remove the O-rings like this. And there are replacement O-rings. They may be like the originals, they may be like these, which are green. And you can see I've used an example here of a O-ring which is swelled. You can see that this brown one is a little larger. And you install the new O-rings. Now, I want to mention that this must be clean and dry, and your hands must be clean. Obviously mine are not, but the objective is that you do not contaminate your new parts with oil and or hydraulic fluid. When you reassemble this, you want everything to be perfectly clean. So you'll use some type of a solvent to remove all the oils from these components, and you'll remove your new O-rings from their package. Again, with clean hands and clean components, you will want to pre-lube these parts only with a silicone-based lubricant, not a petroleum base, because you can actually contaminate these O-rings and cause them to prematurely fail in the future. Now for 2003, this is different than this. We're showing a 2002 model here. And here we have the 2003 clutch cover. We have this seal here, which goes on top, and this brown one is the lower one. The seal goes in the position that I'm holding it in now, with this lip facing up. This would be the 2003 type spring that goes in the center, and it has a stabilizing rod which looks like a nail. The head goes on top. There are 3 bolts which hold the water pump to the engine. When you remove the 3 bolts and pull away the water pump, you can see here in the end of the crank you have 2 options for this pin on the water pump drive to go in the crank. What I do is I move the crank so that one of these lines is in perfect alignment with this screw hole. Then I can do the same thing with the water pump drive. You can see like this that I have it aligned with this screw hole. So then if I move the crank so that it's in alignment here, I want to reinstall the water pump, then I'm certain that I do have this in alignment. There are, on the 3 water pump bolts, 2 are of one length and the third one is longer. The longest one goes on the bottom. I'll mention again that when reassembling the clutch cover, you need to be sure of the alignment of the water pump shaft pin with the crank and the position of the previously explained little foot that's on the kickstart mechanism that falls into this hole here. Not this one, but this one. You can see that it's deeper. When reinstalling the clutch cover, be certain that you do not fold over the lip on the kickstart seal. You must watch this as the shaft is going on and inspect the seal to be sure that it's properly installed. Well, now that we've repaired our clutch components, we must now bleed the clutch system again to remove the air from the hydraulic system. As explained elsewhere in this video, we're going to inject fluid with a syringe into the bleeder nipple, which is on the side of the clutch cover. There are 3 bolts which hold the water pump to the engine. When you remove the 3 bolts and pull away the water pump, you can see here in the end of the crank you have 2 options for this pin on the water pump drive to go in the crank. What I do is I move the crank so that one of these lines is in perfect alignment with this screw hole. Then I can do the same thing with the water pump drive. You can see like this that I have it aligned with this screw hole. So then if I move the crank so that it's in alignment here, I want to reinstall the water pump, then I'm certain that I do have this in alignment. There are, on the 3 water pump bolts, 2 are of one length and the third one is longer. The longest one goes on the bottom. I'll mention again that when reassembling the clutch cover, you need to be sure of the alignment of the water pump shaft pin with the crank and the position of the previously explained little foot that's on the kickstart mechanism that falls into this hole here. Not this one, but this one. You can see that it's deeper. When reinstalling the clutch cover, be certain that you do not fold over the lip on the kickstart seal. You must watch this as the shaft is going on and inspect the seal to be sure that it's properly installed. Well, now that we've repaired our clutch components, we must now bleed the clutch system again to remove the air from the hydraulic system. As explained elsewhere in this video, we're going to inject fluid with a syringe into the bleeder nipple, which is on the side of the clutch cover. And we have removed the fluid from this reservoir, and we're injecting fluid from the bottom. And if in the beginning of this process you find that the syringe has resistance against it and the fluid does not want to flow, then you probably have this screw here on the lever adjusted in too far, which is preventing the piston inside here from opening all the way and opening the small hole in this reservoir. After we verified that we have fluid coming up from below, we will fill the reservoir here partially, and then we will close the bleeder below, and then we can pump this lever here through some long strokes and some short ones, and you will begin to feel that you're getting a clutch. It may be necessary to repeat this process more than once. I also want to mention that it is possible for small air bubbles to stick to the interior of the line. So in this process, you may find it's necessary to tap on the line as you're using the syringe, and you may see that when you do this, additional bubbles will rise up in the fluid. This process should give you a good clutch very quickly. When bleeding the clutch to eliminate the air from the system, you'll find here a small rubber cap. This being the bleeder nipple here, typically it's a 7mm wrench. This bleeder nipple must be rotated a couple of turns for it to completely release from its base. If you find that when you're attempting to inject the fluid here that there's a resistance against the syringe, you either have this bleeder nipple not turned out far enough, or it's possible that you have on the handlebar unit too much adjustment on the little lock screw which is on the lever itself, which I will point to. If this screw and this jam nut, if the screw is in too far, it will prevent the piston from coming out from the master cylinder and allowing fluid to rise into the reservoir when you are injecting it from the bottom. Also, when bleeding this system using injection, you would need to have this cap removed also to allow the fluid to rise into the reservoir, and periodically you will have to take the excess fluid out of the reservoir. GasGas has designed the Pro engine to be easily removable from the chassis for maintenance. I will point out some of the features and the correct procedure to go through to remove the engine from the chassis. To begin the procedure of removing the engine, you would first want to remove the airbox and seat and the fuel tank. Then you will remove the radiator cap and drain the coolant from the engine, and you will drain the oil that's in the transmission. You would then disconnect the chain by disassembling the master link. You can remove the carburetor and set it aside, leaving the slide and the carburetor cap and cable attached, and you can lift it and hang it over the frame. You would remove the cover for the magneto, remove the stator rotor, and then you can take off the stator and leave all the wiring connected, and you can take the stator and hang it up over the frame. This way you don't disturb any of the wiring in the motorcycle. When reinstalling the stator, it is marked and it's not possible to install it incorrectly. You would then remove the components of the exhaust system, the front, mid, and rear silencers. And then you have a motor mount bolt here. There's a motor mount bolt underneath the engine here. And then you have this swing arm pivot shaft, and take note that the engine actually does clamp to the pivot shaft on each side in the rear, so you will need to loosen the two Allen bolts at the rear of the engine case, one there and one on the opposite side. Removing this brass cap from the water pump housing will allow the coolant to drain. You'll capture it with a container under the motorcycle here. You remove this large Allen bolt here, and then the swing arm pivot shaft is driven out from this side, out the other side. You only need to push this shaft out beyond the center cases. You can leave it on the other side, still in the swing arm on the left-hand side. It's not necessary to take off the brake pedal or the skid plate or the radiator. You will then remove the rear cylinder base stud nuts, and there are two bolts that are mounting this brace to the frame up behind where the fuel tank was. You'll remove this brace. If you remove the clutch cover from the engine before you remove the engine, you can actually take the clutch cover off, as I explained elsewhere in this video, and you can set it aside also and never lose the hydraulic bleed of your clutch system. You can leave the hydraulic hose connected to the cover and put it aside, and then take the engine out for the maintenance that you'll do internally. It's possible to remove the engine efficiently in 30 minutes. The bolts on the clutch cover vary in length. Basically, when reinstalling the clutch cover, when you first insert the bolts and before you begin to thread them in, you can see that they have about an equal amount that is outside the cover. So obviously if the bolt is too long, it's sticking up too high, or if it's too short, it falls into the clutch cover before it actually makes contact with the threads inside. There are 3 separate lengths of the bolts on the clutch cover that exclude the ones for the water pump. The longest one is here. The 2 next longest ones are here and here. The 2 shortest ones are here and here. Now I'm going to give you some tips on disassembling the engine. We've removed the clutch cover, and we're going to remove the clutch assembly, and no tools were required. This one came off. There's the washer that I mentioned earlier. It sits here on this transmission shaft. On the back of the engine here, we have where the reeds and the carburetor manifold are. We have a spacer plate. I've already removed the manifold. I've removed the intake manifold, and I want to point out about this spacer plate. I'm showing it here installed incorrectly. There is a more narrow end here. This would be correct here. And there is a gasket on each side of this. I have made a wood square with lumber for holding the engine while I work on it. After removing the 4-cylinder base nuts, it may be necessary to tap lightly on the cylinder to release it from the engine cases. We lift the cylinder off, being careful to catch the piston as it comes off. On the piston, there is an arrow for the piston's direction. The arrow would be to point forward. It's under this carbon, which you'll find it when you clean this piston before reassembly. Also, the back of the piston is always where the 2 little pins are and where the opening of the rings is. When you're reinstalling the cylinder, obviously you have to compress the rings, and they have to be in a position where they're compressed with the gap right where the little pin is in the groove there. This is the back of the piston. During assembly, GasGas may use only one or more than one base gasket under the cylinder. This would be to properly set the deck height and squish of the cylinder head. We will remove the base gaskets. I like my little hobby knife. It works very well for things like this. To remove the piston, you have on each side a spring clip, and you grab it like this and rotate, and there it is. On reassembly, it's always prudent to put a rag down inside around the piston, so when you're installing these clips, there's no possibility that it can drop down into the crankshaft area and be lost, where it would be difficult to retrieve it. I've pressed the piston wrist pin out far enough to release the piston from the connecting rod. You have this needle bearing, and we're going to set the piston aside. Now we're going to separate the center cases. I removed the center case bolts. There's one here and here and here, and then there are bolts inside here, and we have one up here above the reed cage. I would like to point out that this bolt here is going through the center of an oil passageway, so we do have a copper washer only on this one here. These center cases are designed to be easily taken apart, and there's just a very, very mild fit here. To separate the cases initially, you just have to take a rubber mallet, and in this area right here, very lightly, you should only need a tap. And you can see that the cases have opened up. When we take apart the center cases to gain access to the crank and transmission, we're going to leave on the right side or clutch side of the engine the clip on the primary drive gear, the clip on the shifting mechanism for the shift drum, and this would be the clip on the kickstart idler gear, which is on the transmission secondary shaft. It's not necessary to remove these clips at this time. The cases on this engine are not split in the center. They're off-center. The left-hand case is actually a cap. And this is the reason that I leave those clips. We're going to leave all the components of the engine in the right case hab when we take it apart. So we have the engine on its side, and we lift off the left-hand case half side like this. And there is our center gasket, and we have all the components still in the right case hab. Now I want to point out that there is a bushing that is on the countershaft seal here that slides over the secondary shaft, and this bushing has 2 O-rings. So when you reinstall this bushing after the engine's reassembled, be certain that you keep track of these components. We're going to show it this way without the case, but the purpose of these O-rings is that when this bushing goes on here that rides on the countershaft seal, that the O-rings are actually sealing the bushing to this shaft like this. This way it prevents oil from passing behind the bushing and out around the countershaft sprocket. When the transmission is in the neutral position, this shaft spins freely. I'm going to take out the shifting forks. We'll just extract this shaft here. And we have 2 shifting forks. And to check these to see if they're bent, you put them together like this on a shaft, and they are good if they pass each other without interference. If they're bent, you can see that they are not perfectly flat when they touch each other. These would be good ones. On the primary shaft shifting fork, there's only one. We can remove the shaft. The fork comes out with this gear cluster. If you're not removing the crankshaft itself for crankshaft maintenance, it's not necessary to take off this circlip or to remove this gear. If we're doing transmission maintenance and we're removing the transmission, then we would be removing the circlip here with one of these circlip tools, and this small circlip here that's on the shifting drum. After removing this circlip, we have a washer. After removing this circlip here, we have a washer, we have a bearing, and another washer. And this washer's recessed, so the best way to get a hold of it is just to use a magnet. Keep these components together like this. This way when you're reassembling it, you're not confused. Here we have a lever arm with a small wheel which holds tension to the shift drum. This holds the transmission in each specific gear. It's not necessary to really remove this arm. However, you do have to relieve the pressure of this spring. And to do so, first we will release this Allen slightly, like this. Then you do need to draw the spring back, and I'm going to use a large punch, which is the correct size to drop it in the engine like this. And then you can use it as a lever to pull the spring back off of the bolt, and then the bolt can be removed. And on this bolt is a bushing, and be certain that you have this bushing with the groove that the spring sits in, like it's shown here, the groove being on the top part of the bushing. It is possible to have this bushing installed upside down, so make a note of that. Removing the bolt, we can then release the spring tension and pull the arm back. Again, I like to keep components together like this, then I don't have to remember how this went. So then we're going to remove this shaft, and this disc and this gear will stay because they're under this gear. Now we're going to pull them off exactly like they were and put them back on the shaft so we don't lose track of our components. And we have a washer here. Okay, now when reassembling, I'm going to point this out. You put the washer, then the gear and the little disc down in here like this, and then you center them with your finger, and then you put the shaft in. And this is because these are under this gear here. I use a rubber band to hold the parts together when I have them outside the engine. This way I don't lose track of the components. Now we will extract the primary shaft for the transmission, and here is the fork. Keep in mind that if you do not have the crank removed when you're reassembling, that this fork needs to be in here like this when you're putting the shaft back in the engine. These pins that are on the forks, this little pin, actually rides in the grooves that are on the drum. This is the way that the transmission shifts. As the drum rotates, the little pin travels through the channel and moves these discs on the transmission. There's 3 of these discs, and they have holes in them. And then when the transmission goes in gear, this disc moves over and falls into the little pins that you can see on the side of the gear. So this one being freewheeling, and now this disc is connected to this gear. And then when this pin travels through the drum and moves, it moves the disc to this gear. And the neutral position is when all of these discs are in the center. This way none of the gears are connected to the 3 discs. I'm extracting the shifting drum and shaft, and we have this piece here with the spring and the shaft and drum. This passes through the engine case, and then this goes on the end of the shaft, and then it falls into the slot in the end of the shaft, and we showed previously the washer and circlip. This post is for adjusting the position of the shifting mechanism, and you may be able to see here that the post is actually an eccentric. So when you loosen this Allen, you can put a wrench on this post and rotate it up or down, and this eccentric will move this little arm here, which sits over the post like that. And when this arm moves up or down, you are moving the shaft that this is connected to, and essentially adjusting the position of the drum in relation to the forks and the gears. Now what you're doing is you're aligning these 2 little wheels here, which are spring loaded, and they fall into these little divots. You're aligning these 2 wheels centered in the drum with the little arm and wheel here that I showed previously, which it falls into these outer stars here. So by making the adjustment of the eccentric, you are aligning these wheels and this wheel so that they are laying down in their respective recessions at the same point. Now, I want to point out that the stars on this drum, that the neutral position is the one that is like this. Now when you're reassembling this mechanism, you will want the wheel here to be resting on neutral. This way when you reassemble the transmission, you can spin the gears freely as you're checking your work. Under this shaft, when you remove the drum, you'll find a washer. And again, you can use your magnet to get the washer and extract it. And again, we're going to put it on the shaft so that we don't forget where it goes. I've extracted the shaft from the drum, and they go like this. And we have 2 washers. I'm going to set them there where they go and set this drum aside, and I'm going to explain this mechanism here. In the case, we have this recessed area that these wheels, which they're spring loaded, they go down in this recessed area. When reassembling this mechanism, I would have the drum on this, but this is for clarity. These wheels are in the wider part of this opening, like this. You can see how this area here is wider and this is narrower. When you're changing gears, when you downshift, this wheel pulls into the narrower area, which retracts it and allows it to move a position inside the interior of the drum. When you upshift, this wheel over here falls into the tighter area of the radius and it is retracted. This is how the drum moves through each gear. Each time you make a position of the lever, it moves the wheels into a new position in the interior of the drum. And then this arm is holding the drum in the specific gear position that you're in. And this is why that adjustment with the eccentric on the opposite side is necessary, so that these two components are in perfect alignment. You may need to make that adjustment when you have some difficulty with the transmission when you're shifting down from higher gears. If the transmission is reluctant to downshift, or that you have some false neutrals, then you can adjust the small eccentric, and that will align these and return your shifting mechanism to normal operation. During reassembly, always use a new center case gasket. Always be sure that there are two of these little alignment pins, that they remain. There's one in front of the crank and one here on opposite ends. Be sure that they remain in the right case half, because they hold the gasket in position during reassembly. After you've returned everything to normal, your transmission is in neutral, and you've installed your base gasket, there is some excess gasket which hangs out here at the reed cage and up on top here. Put the gasket behind the crank arm. When you're putting the case back on, be certain the crank arm is pointing out through the hole. If it's back over here, it won't be possible for the cases to go back together. When you're done putting all the bolts in the center cases, and you will start tightening the bolts from the center, and you will work your way out. Be certain you have proper operation of the transmission by spinning the shafts and working the shifter before you trim away the excess gasket material. In the left case half, you have this plastic piece. This is the kickstart return stop. Inspect it for damage, and if it has any wear, replace it. You have a kickstart return spring here that's sticking up out of the right case half. So when you're putting this back together, you have to be certain that this spring goes in that hole in the left case half. This is the one thing you have to be certain on your alignment, is to put that spring in there, like that. There, when you're putting the cases together. Well, I'm going to take a few minutes here and explain some things that are on the clutch side of the engine. The kickstart mechanism, this spring here that holds tension to retract the kickstart lever. This long end goes down into a hole there, and then counterclockwise you must rotate this whole assembly one time before you put it in the motor. This is what preloads the spring. I've made a tool out of a Kickstarter, but you can also use your Kickstarter lever as your tool. Here we have it in position. Okay, now I want to mention that this little piece here, it is going to be facing this hole in alignment with the center of the shaft and this hole. What this piece does is, when you're using the kickstart lever, this piece is in a recessed place in the clutch cover, so it actually pulls the gear up so that it rises up this twisting spline here, so that it makes contact with the kickstart drive gear, which is here. You can see how it rises up and comes in contact with the gear. And then when it rotates this gear, it rotates the clutch mechanism, which starts the engine. I want to mention briefly about snap rings or circlips. There's an inside type and an outside type. Many people don't realize that there's two sides to a circlip. These are stamped by a machine tool. This would be the dull side. And you may be able to see, but you can feel that this is rounded and smooth here. When you turn it over, this has a sharp edge. Now, when a circlip is on a device which applies pressure to the clip, the sharp edge should be facing away from the direction of the pressure. So if the pressure is being applied this way, then the sharp edge should be here so that this clip has a good grip in its groove. An example would be the clip on the front sprocket. The sharp edge should be facing out so that if the sprocket is pressing outward on the clip has a really good bite into its groove. It's very important that you check this, especially on internal engine and transmission components. If you're going to have something apart, be sure that you check the position of your clip because they are symmetrical, so if you don't notice which way it goes, it's possible to install it backwards, which could cause problems later. Okay, so we're showing you how to work on your engine, and a competent mechanic will find these hints very helpful for this procedure. If you don't feel confident on doing this type of work, please don't attempt to do so. And if you have any problems, and if things don't go together like they should, be patient. Take the time to find out exactly what it is that is causing you an obstruction during reassembly. It's unwise to pound, pry, or beat on engine components. Typically, you will cause damage. Experienced mechanics will tell you that your patience is a virtue, works best in the engine repair, and always try to remain as clean as possible. Wash all of your parts in a solvent before you reassemble, and it's also best to lubricate all the transmission components with a light spray oil or something. This way, when you're testing the transmission to see if it's shifting properly and so forth, remembering that the engine actually doesn't have oil in there, that pre-lubrication of all the components is going to let them move more freely, and then you can get a better judge of the operation of the components. Also the same with the piston. You should lubricate that piston with some motor oil or a lightweight oil before reassembling. This way you don't scratch any surfaces inside the delicate bore. Also, being certain to be very clean.
After the engine has been reassembled, or if the bike is not shifting properly, the transmission shifting point can be checked as follows. Put the bike on a stand, and by rocking the back wheel back and forth, put the transmission into first gear by using your hand. Keep hold of the shifter lever and let it return to neutral very slowly. Just prior to the neutral position, you should hear a click as the internal shifting ring positions itself for the next gear. Also do this check by upshifting to second gear and noticing the click just prior to the lever again returning to neutral. If the click is not heard, or you have to push the lever up a bit to get it, then the transmission needs to be adjusted. This adjustment is on the right side of the engine, and the clutch cover and clutch assembly must be removed. The eccentric is located between the ends of the shifting return spring and is basically an oblong-shaped post which can be rotated. This rotation moves the centering of the shifting spring, which in turn changes the centering of the transmission shifting shaft. Again, put the bike into low gear as previously shown and let the shifter come up slowly. If there is no click, then loosen the lock bolt slightly and, with a 10mm wrench, turn the eccentric so the spring assembly moves in an upward direction until you hear the click. Stop here and tighten the lock bolt. If second gear were the problem, the eccentric would be turned the other direction to move the spring downward. Put the clutch assembly back on for now to hold the transmission input shaft from moving and check the gears again. It's possible you may have to do this several times to obtain the correct adjustment. The Kickstarter lever must always be positioned approximately as shown here as it comes from the factory. This is the position which provides the most rotational force when starting the engine. Do not change the mounting position of the lever any farther forward because this can damage the internal starting mechanism. The foot peg is the mechanical stop for the lever, and it is normal for the lever to contact the foot peg when starting. This is the rearward limit for the lever, and any movement past the foot peg can also damage the internal starting mechanism. If the engine hesitates when the throttle is opened quickly, the low-speed idle fuel mixture screw needs to be adjusted. First, set the engine to a very slow idle by turning the idle screw counterclockwise. Then, turn the fuel screw all the way in and then back it out 1/2 turn. Next, momentarily crack the throttle open and note the engine response. If it hesitates, the pilot fuel circuit is too lean and must be enriched by turning the fuel screw 1/2 turn out or counterclockwise. Then crack the throttle again and note the engine response. Keep repeating this procedure until the engine responds immediately. At this point, go one more 1/2 turn out on the fuel screw, and this then becomes your final adjustment point. If the fuel screw is turned more than 3 turns out and the engine still hesitates when the throttle is cracked, then the pilot jet is too lean and must be replaced with a larger size jet. This procedure must always be accomplished whenever the carb is rejetted with a different main or pilot jet.
In this segment, we will explain how to remove and exchange the fork seals on the front forks or front suspension of the 2000 and 2001 and 2002 model GasGas trial motorcycles. In front of me is a left side fork leg beginning in 2000, and in 2001, 2002 we have a cast lower leg that looks like this being the left hand side. To exchange a fork seal, we will first remove a bolt that looks like this, which has a sealing washer, from the bottom of the fork leg here. Okay. Then we will unscrew the top of the fork here. The internal part of this leg is threaded and this cap is threaded, and then you can extract the entire interior of the fork leg like this. Note before reassembly, put your bolt back in here and pull on this to be certain that this insert here is all the way out. It's possible that it can be pushed in like that, see, during the disassembly process. So pulling on it like that, see? Okay. You'll remove the dust wiper from the fork leg, which is this piece. And it's kind of like a seal, but it's primarily to keep the dust from entering the fork. Has a spring here. Then underneath it you'll find a snap ring, which you'll remove with a small screwdriver. It has flat spots on it to allow you to get your little tool underneath it. Then when you pull the two pieces apart like this, the seal will come out with these other components, a flat washer and 2 Teflon bushings. Okay, this is your seal. Now, when you have your new replacement seal, you'll see there's a spring side. The spring side faces down or into the interior of the fork leg. You should lightly lubricate the seal inside the lip area here and on the exterior with a white lithium grease or a silicone lubricant. Then you will first place the plated leg into the lower leg like this, and then this upper bushing will fall into place into the lower leg, and you can use your old seal to help press this together like that, get it started, and then you take your new seal and put it on the fork leg, and then place your old seal on top of your new seal, and you can tap this seal down in. Then remember, don't use metallic tools for installing the seal, because it's possible that you can scratch the plated leg. So when this is pressed down in there and the groove appears that this ring seats in, you'll then install the ring, and then the wiper goes on there, and then you can put the interior of the fork back together, and then to fill it, when you have the interior in it, like this, you'll just pull the leg down a little bit, like that, and then pull this to the side, and then pour in the oil like this. And you may have to go slowly, because as it gets almost full, it's possible to overflow it. It takes a little time for it to drain down into the dampener. The amount of oil you will put back in this fork is 300 cc's. That is 300 cc's on either side, right or left, and the proper weight is 7-weight fork oil. Now, 300 cc's is after this fork has been disassembled and completely drained and cleaned. I want to mention that when you have this apart for seal replacement, it's a good idea to wash out the interior of all the parts to be certain that all the contaminants from the previous oil have been cleaned out. This way you don't contaminate your new oil. Okay, for those of you who really want to do this job right, maybe make a couple of tools, here's a tip. I have PVC pipe. It's 1.5 inch interior diameter. This piece of pipe can be used as a seal driver. So we're going to just slide it over the tube, and like this, we can drive the seal in. And a longer piece you can have, and you can hammer on the end with your rubber mallet to drive in your seal. Works really well. Hardware store item. Also, I want to mention that when you reinstall the fork leg on the motorcycle, you should clean this surface of the leg with a solvent or soap and water or window cleaner, and clean the interior of the commonly known as triple trees. If oil is left on this area where the leg is clamped into the motorcycle, then it can cause the forks to twist, and these surfaces being clean where they join with the triple trees is important. And when you disassemble your fork leg, take note of how much of the leg appears above the top triple tree. You may want to take a measurement before you take it apart, so that when you reassemble, you have the fork leg correctly positioned in the triple tree. And I want to mention again also that we do not over tighten any of the bolts on these assemblies. If you use too much force, it's possible to crush some of these parts or damage the aluminum triple trees. So use care when you reassemble your front suspension. And about the wiper, when replacing this, it's possible that you may find it a little bit difficult to install. A little hint, you can put this in some hot water and let it sit for a few minutes, and it will soften it, and it will install much easier. And this is when you're especially talking about a new part, the one that if you're reusing the old wiper, it probably will be no problem. But a new one, you might soften it in hot water. The hydraulic fluid that's installed in your hydraulic clutch and your front and rear brake systems by the GasGas factory in Spain is DOT4. You can also use DOT5. It's available from auto parts stores nationwide and even at the department stores in the automotive department. I'm going to show you a few little tips about bleeding these systems to remove the air, make this a lot easier. I went to a farm store. Now, these may be available in your region or may not. Here in Indiana, we buy these at the farm store. It is a veterinarian syringe. On the end here where the needle goes, I've installed a rubber hose. Now, you'll draw the .4 or 5 fluid up into the syringe from the fluid container, and this way you can inject under pressure the fluid into the system. This works much better than the pumping of the lever or the pedal. This is very quick and very easy. On the rear brake, the way to bleed it we find best is to remove the inlet fluid hose, which this comes from the reservoir, so this is not under pressure. So I pinch it off with hemostats and remove it. Then I plug into this nipple here on the master cylinder with my syringe. Then I open the bleeder nipple on the rear caliper and attach a bleed hose which goes to my small jar. And when I open this, I can inject the fluid in through this nipple here, and the fluid goes through the brake system, fills the caliper, and comes out through the bleeder nipple. Now, if you use a clear hose on this end here, you can see when the air bubbles have stopped coming through the hose. And then while still maintaining a constant pressure on the syringe, close the bleeder. Now, if you run out of fluid when you're near the end of your travel, keep the wrench on the bleeder and close it. Then you can get more fluid and do the procedure again. Now, on the front brake and the clutch, you want to also inject into the front brake caliper on the caliper itself with the cap removed from the master cylinder on the handlebar. You will see the fluid rising up into the reservoir, and be careful because if you're pressing hard on this caliper, on this syringe, the fluid will shoot out of the master cylinder and hit the ceiling. But air naturally wants to rise in the system. So when you're bleeding the clutch or the brakes, when you're pumping with the lever from the handlebar, you're pressing those air bubbles down through that hose. But then when you release that lever to get the next stroke, those air bubbles naturally rise back up again. So you're moving an air bubble back and forth, and you don't really get much done. When you inject the fluid from the bottom, it forces all of the air that's in the system to rise, and it comes up out of the top of the reservoir, and you'll find that your bleeding procedure is very quick, and you'll have very solid brakes.
On the Pro, the master cylinder is set up differently. The inlet fluid supply and pressure connections go into the front of it, and it is difficult to reach the inlet connection to inject the brake fluid. You can see this line just to the right of the swing arm. Instead, it is easier to connect to the same supply line as it comes out of the master fluid reservoir. Remove the fluid from the reservoir, disconnect the supply line, and attach it to your injector syringe. Now, with the bleeder valve open, you can force the brake fluid through the system, which will force out any air in it. If you don't have a syringe to do pressure bleeding, the system can also be bled by pumping the rear brake lever. However, this is much slower because of the short travel of the lever. To speed this up, the brake lever can be removed by removing the 19mm bolt that holds it to the frame and then using a T-handle Allen wrench to apply longer strokes to the master cylinder as you open and close the bleeder. This moves more fluid through the brake line to remove the air. Pressure bleeding can also be accomplished by connecting your syringe to the bleeder. Be sure to remove the fluid from the master reservoir first, then open the bleeder and force the fluid backward through the system. Watch for air bubbles to come into the reservoir, indicating the system is being bled. If you are still having a problem bleeding the system, try elevating the rear wheel as high as you can to get the air bubbles to travel up to the caliper. Then try the pressure method again from the master reservoir supply line. The silver braided pressure line that goes to the caliper from the master cylinder should be checked to be sure it is installed correctly. On a new bike or when maintenance is done to the master cylinder, this line must come out of the master cylinder at a 90-degree angle. If it is lower, the swing arm will hit it and cause it to rotate upward, causing a loss of brake fluid and pressure when the rear brake is applied.
When you first assemble your motorcycle, you may wish to take the time to add some additional grease to the wheel bearings on the front and rear wheel. You can do this by using a small pick instrument to remove the wheel seal, and then you can add the grease and then press the seal back in place, and it's done like this. You put the instrument very carefully under the edge of the seal and pick it up. You can see that it comes right off of the bearing. You can see this original bearing here has very little grease. This is just the way that they're produced. So you're filling this area with grease, forcing it down in there, then you put the seal back in, and then take your rag and wipe off what grease oozes out, and you have your bearings super greased. If you feel that your motorcycle may be running too hot and you wish to check the fan and or the thermostat, an easy way to check the fan motor to see that it's operating correctly is to disconnect the two wires on the thermostat and take a little jumper wire or a paper clip, whatever, and connect the two thermostat wires together, and this will make the fan run constantly. You can also do this in an emergency if your thermostat should fail and you need to continue to ride. When you remove the cylinder head, you will notice two O-rings. It's possible that these O-rings may be reusable, but we recommend that you replace them. When replacing them, put a light coating of grease on the O-ring. This will help the O-ring to stick in its groove when you're reinstalling the cylinder head. The GasGas motorcycle is designed for ease of maintenance. You will notice that your cylinder can be removed without removing the engine from the chassis. To remove the cylinder, you must remove the two cylinder stay braces, which attach from the base of the cylinder to the frame on either side. You must, using the Kickstarter, lower the piston to the bottom, and you must disconnect the water hose from the cylinder to the water pump. Once we've removed the 4 cylinder base nuts and the 2 cylinder stays, you can remove the cylinder by very lightly tapping on it to break it loose from the base gasket. Lifting upward, the cylinder comes off very carefully now so as not to damage the piston. You will see that you may have more than one base gasket. This is when the factory assembles the engine to get the correct measurements of the ports. They will use different width gaskets or a combination of gaskets. Very gently we remove the cylinder from the piston. You will turn the cylinder on its side and you can remove it from the frame like that. The cylinder base gaskets are available in different widths, and you can get specifications from your GasGas dealer to properly measure and set up your cylinder porting depth. The GasGas Trials motorcycle uses a Nicosil plated cylinder bore. The cylinder cannot be bored as in some types of motorcycles. Most Trials motorcycles in use today have Nicosil or chromium plated cylinder bores. If you need to have the cylinder serviced, we recommend that you see a professional familiar with chromium and or Nicosil type cylinders. It is possible to replace the piston ring, and when you fit new rings to the piston, you will need to insert the ring into the cylinder, and using the piston to center the ring, you press it down into the cylinder bore, and then you'll want to check your ring in gap. In this particular example, it's too wide. The standard for ring in gap in GasGas Trials motorcycles is 0.1 or 1/10 of a millimeter per inch of cylinder bore. The 238 cylinder, which I am holding, uses a almost 3-inch bore, so we would recommend that the piston ring end gap would be 0.3 millimeters, which you can use a feeler gauge to check between the ring end gap. Of course, like I said, this is much too wide. I'm using a worn piston ring here as an example. For clarity, we have removed the linkage pieces and shock absorber and reassembled them for you to see how the mechanism is assembled. This is the lower shock mounting bolt. Again, an 8mm Allen wrench removes it. This center linkage piece, the two dog bones. This part attaches to the swing arm. It has two cage needle bearings and two oil seals, one on each side, and the 13mm wrench. This is your large suspension pivot bolt and the two dog bones. The 8mm wrench again is used to remove the large suspension pivot bolt. This is your dog bone. It has needle bearings inside and an oil seal on each side to keep water and dirt from entering the bearing. These bushings, there are two types. This one, which fits the larger bolt, and a very similar one on the opposite end, which fits the smaller bolt. When taking this apart to grease the components, you must inspect thoroughly the needle bearing to make sure that it is intact. Also inspect the surface of this bushing. Sometimes when your suspension parts become worn, these bushings and needle bearings will transmit to play in your rear swing arm, and if that's the case, they will need to be replaced. To replace the needle bearings in the dog bones, you can drive them out with a socket that is of the suitable diameter. Also, there are optional needle bearings available which have oil seals built into the bearing. See your GasGas dealer for a choice of the optional bearings that you may use.